Before we start with this lesson, please quickly type Bahula Clinton on YouTube and subscribe, or hit the link in my bio and subscribe. Join me in hundreds of videos just like this. In today's video, we are talking about momentum, delivered by SirGuru. Right. So, ladies and gentlemen, without wasting time, let's get to it. So, the definition of momentum is the product of an object's velocity and mass. So, momentum is the quantity of motion an object has. So, an object that is not moving does not have momentum. But an object that is moving, regardless of at what velocity or speed, it automatically going to possess momentum. And the mathematical formula for momentum is P equals to M times V, where everything is small letters. You need to know that all variables are small letters. P stands for momentum, small m stands for mass, and small v stands for velocity. And it is very important to know that the SI unit for mass is kg. So when we substitute mass, we're always going to use kilograms, right? And then the SI unit for velocity is meters per second. And when we multiply those two SI units, we get the SI unit for momentum, which is kg meters per second. Right. And the other SI unit for momentum is newtons seconds. We're going to talk about this later when we talk about impulse. But for now, it is very important to know that mass is a scalar quantity, so it can only have a magnitude. Velocity is a vector quantity, so it has the magnitude and direction. So velocity is going to have magnitude and direction. Now, it is in fact mathematically allowed to say that the multiplication of a scalar by a vector will result in a vector. So mass being a scalar and velocity being a vector, and they are multiplied together, it means our momentum is also a what? Is going to be a vector, right? Momentum will be a vector. So it also takes the direction, and that direction will be the direction in which the object is moving at, or the direction of the velocity in simple terms. So now, momentum is directly proportional to mass and velocity. What this means is, if the mass is higher, the momentum will also get higher. If the mass is smaller, the momentum will also be smaller. Same with the velocity. Perfect. Now, as I said earlier, momentum is a vector. It has both magnitude and direction. Remember, vector has both magnitude and direction, but a scalar only has magnitude. Now, let's look at the vector nature of momentum. Momentum will always point in the same direction as the velocity, right? Momentum is a vector because velocity is a vector and mass is a scalar, and the product of a scalar and a vector always results in a vector, right? If two objects have the same speed but different masses, the heavier object has more momentum. So it's like our masses are the same, but we are moving with the same velocity. The man who has the highest mass is going to have the more momentum. So the heavier the object, the more the momentum. Now, objects having different speeds can have the same momentum if their mass compensates for the velocity difference. Right. Perfect. And then now, here are a few examples that I've put for you. A car traveling at 120 kilometers per hour has more momentum than the same car traveling at 60 kilometers per hour. It's like you have two VW Polos, same model, same year, same size, and you put them on a race. The one that is traveling faster will have the highest momentum. Alright. Now let's do some examples. A soccer ball example. So guys, here we are given the mass of 420 grams. But we need to remember that a mass cannot be measured in grams. The SI unit that is allowed is kilograms before we substitute into any equations. So I have to convert the 420 into kilograms. So that is easily by dividing that number by 1,000, which gives me 0.42 kilograms. And the mass doesn't have direction because it's a scalar. Now we are given the velocity of 20 meters per second. The velocity must always go with direction because it is a vector. Right, and we already know the direction of the momentum is going to be toward the goal, because the direction of the momentum is always the same as the direction of the velocity in question. So to do the calculation of momentum, we're going to write the formula down to say P equals to M times V, and then we put in our values, so 0.42 kgs and 20 meters per second. And when you substitute, it's not necessarily important to write the units, as long as you are going to remember to write them at the end. All right. And the answer becomes 8.4 kgs meters per second. But we need to include the direction because that is the same for the velocity and momentum. Right. Now let's go to the second example, the cricket ball example. We are given a mass of 160 grams. Obviously, we need to divide that by 1,000 so that we can have kilograms, which is the allowed SI unit for mass. So 160 divided by 1,000 is going to give us 0.16. And then velocity equals to 40 meters per second towards the batsman. And then following like previous example, you write the formula down, you substitute correct SI units. So the M will take the 0.16, not the 160 grams. It will take the 0.16 kgs. And then the velocity is 40 meters per second. And when we punch that into our calculator, we get 6.4. But because it's the final part of this step or this solution, we write the unit, which is kg meters per second. If you want to hear, you can say newtons dot seconds. Is still allowed. All right. That is perfect. Let's proceed now. They say, and then we also need to show that the direction is towards the batsman, because the velocity's direction is the same as the momentum's direction. Right. And ladies and gentlemen, thank you for watching this video. And once more, if you found it helpful, don't forget to hit the subscribe button on my YouTube channel. Aluta continua. Tango.